Imagine waking up tomorrow morning and the news says, the first humans just landed on Mars. No movie, no simulation, real people standing on another planet. Now here's the question nobody is actually answering. What happens after they land? Because getting to Mars? That's hard. But surviving Mars? That is a completely different monster. Today, we are going to find out, can we actually survive on Mars? Before we talk about surviving, let's talk about why we even want to go. Here's something uncomfortable. Earth is not safe forever. 66 million years ago, a single asteroid wiped out the dinosaurs. Every single one. Gone. In a matter of days. Now, scientists like Stephen Hawking and Elon Musk have been saying the same thing for years. If humans want to survive as a species, we cannot stay on just one planet. We need a backup. And out of all the planets in our solar system, Mars is the only real option. Why? Venus has temperatures of 450 degrees Celsius with clouds made of sulfuric acid. Jupiter and Saturn have no solid surface. Mercury is basically a frying pan. But Mars? Mars has a solid surface. A day that's only 37 minutes longer than ours. Real seasons. And most importantly, it has water. Frozen, buried underground, but it's there. Mars is like Earth's abandoned cousin. Rough around the edges, but fixable. Maybe. Here's your first survival challenge, and you haven't even landed yet. The trip to Mars takes 7 to 9 months. That's not a flight. That's nearly a year trapped in a spacecraft the size of a few rooms. During that journey, your body is floating in zero gravity. And here's what that actually does to you. Your muscles start wasting away. Scientists estimate up to 15% loss of lean body mass on a Mars trip. Your bones? You lose 1 to 2% of bone density per month without gravity to load them. Your heart weakens. Your vision can actually change. Fluid pressure builds up behind your eyes and reshapes your eyeballs. And then there's radiation. In space, there's no magnetic shield like Earth has. You're being hit by cosmic rays constantly. A round-trip Mars mission could expose you to over 1 sievert of radiation. That's roughly equivalent to 10,000 chest X-rays. The cancer risk goes up significantly. NASA has an acronym for the 5 biggest threats to humans going to Mars. They call it RIDGE: radiation, isolation, distance from Earth, gravity fields, and hostile environments. That's basically 5 different ways Mars is trying to kill you before you even land. Okay, you've survived 8 months in space. You've landed. You open the hatch. What do you see? A vast, red desert. Sky that's a dusty pinkish brown instead of blue. Temperature outside? Negative 60 degrees Celsius on average, sometimes dropping to minus 125. And here's the brutal truth. If you took off your helmet right now, you would be unconscious in 15 seconds and dead in under 2 minutes. Because Mars' atmosphere is 95% carbon dioxide and only 1% the thickness of Earth's. There is almost nothing there. So every single second you spend on Mars, you are dependent on technology to stay alive. Problem 1. Breathing. Scientists have already solved a piece of this. NASA's Perseverance rover is carrying an instrument called MOXIE, and it has successfully extracted oxygen from Mars' carbon dioxide atmosphere. It produced 12 grams of oxygen per hour in tests. A larger version of MOXIE could supply breathable air for a small crew. Problem 2. Temperature. Your habitat needs to be pressurized and temperature controlled at all times. Any failure in that system is fatal. This is why engineers are designing multiple redundant life support systems. If one fails, another takes over instantly. Problem 3. Radiation on the surface. With no magnetic field on Mars, radiation hits the surface directly. 1 year on Mars gives you the equivalent of 8 years of radiation exposure on Earth. The solution? Go underground. Researchers have found that just a few meters of Martian soil above a habitat absorbs enough radiation to protect humans. Subterranean habitats carved into the rock might be the most practical long-term solution. Mars is actually full of ancient lava tubes, massive underground caves, that could serve as natural shelters. You can't bring everything from Earth. That's just math. It costs millions of dollars per kilogram to launch anything into space. A Mars colony needs to live off the land. Water. Here's genuinely good news. Mars has water. Lots of it. The polar ice caps contain millions of cubic kilometers of frozen water. And just below the surface, in many regions, there is subsurface ice. Scientists believe we can drill down and heat that ice, extract the water, and purify it. That water solves multiple problems at once: drinking, farming, and through a process called electrolysis, splitting water into hydrogen and oxygen. It can even produce breathable air and rocket fuel. Food. This is where it gets creative. Mars soil has toxic chemicals called perchlorates that kill plants. So traditional farming is off the table. Instead, researchers are looking at hydroponics and aeroponics, growing plants in nutrient-rich water or mist, inside controlled domes, with LED lighting. NASA has already successfully grown lettuce on the International Space Station using this method. Scientists are also exploring algae bioreactors, lab-grown protein, and even insect farming as high-efficiency food sources. Not glamorous, but effective. Two main options. Solar panels work on Mars, though sunlight is about 40% weaker than on Earth. And nuclear power. A compact nuclear reactor provides consistent power regardless of dust storms or day-night cycles. Experts suggest a combination of both for redundancy. We've talked about all the physical threats, but there's one more, and it might be the hardest to solve. The human mind. Imagine being 225 million kilometers from every person you've ever known. A message home takes between 3 and 22 minutes just to arrive. Video calls? Impossible. You can't call your family in real time. You can't ask for help in an emergency and get an answer for 45 minutes. Studies from Antarctic research stations, which simulate Mars isolation, show that confined groups develop serious psychological stress after months together. Conflict, depression, cognitive decline. And on Mars, there's no rescue mission coming if someone breaks down. This is why psychologists consider the mental health challenge just as critical as any engineering problem. The solution involves careful crew selection, structured routines, virtual reality environments to simulate nature and open spaces, and yes, probably AI companions trained to provide emotional support. So when does any of this actually happen? SpaceX had ambitious plans to send uncrewed Starship missions to Mars in 2026. But in February 2026, they announced a delay of 5 to 7 years to focus on lunar missions first. So realistically, the first crewed Mars landing is now looking like the early to mid-2030s at the earliest. China's Tianwen-3 mission is planned for 2028, aiming to return Mars samples to Earth by 2031. NASA's Perseverance rover has already collected dozens of rock samples in Jezero crater, samples that could contain evidence of ancient Mars life. And MOXIE, that oxygen experiment, has already proven you can breathe on Mars using Martian air. That's not science fiction anymore. That happened on another planet. So, can we survive Mars? Not yet, not easily, not safely. But here's the thing about humans. We don't survive things because they're easy. We survive because we refuse to stop trying. Every problem we've talked about today has a team of scientists working on it right now. The radiation, the food, the water, the psychology, all of it. Mars is not a destination. It's a test. A test of whether we are smart enough, brave enough, and determined enough to become more than just an Earth species. And honestly, given everything we've already accomplished, I think we're going to pass. The red dot in the night sky isn't just a planet anymore. It's a question humanity is getting ready to answer. Stay curious. And if you're watching this in the 2040s from a Mars dome, you're welcome.